hardened joints?
Usually like only low angles. Low angles. So there's a certain limit to the angles.
Or what do you have? What's the consequence?
So basically, risk of binding when exceeding the angle, the joints will like, let's say this is a straight, and then one will go like this. It creates like, what you call it?
Usually it creates vibration.
Yeah, vibration.
So
Because
some cars, they need to balance the shaft. So there's like one part travels more, so it with the momentum it creates vibration. So this is when you drive at high speed, you hear a growling sound.
Okay.
Sometimes.
The wear of
The bearing inside
the bearing
is
inside.
Well, there is the bearing and there is the unbalanced shaft. But even brand new, if you have a fresh U-joint and then you have something like that, what happens to the velocity? That's the keyword there. Go ahead and Google velocity profile U-joints. Okay, do you see the curve? What happens there at an angle? I mean, if it's straight, then it's perfect, same velocity. But at an angle, what happens to it? There is a fluctuation in the velocity, right? So these two shafts actually rotates at different velocity depending on the angle of the U-joint. And so that causes the vibration at an angle. Okay? Now you can do a double U-joint, which kind of cancels that, offset. Okay, you offset the angles. However, a more stable solution is the constant velocity joint. Okay? So here comes. The constant velocity joints operate on these lobes. So you have spherical balls that can actually slide left and right. Okay?
Of the engine to the driving unit, even when the drive shaft is positioned at various angles due to the vertical movement of the wheels. Its function is to transfer the power transmitted from the transmission.
Okay? So this is how it's constructed on the constant velocity joint. Its purpose is to achieve constant velocity, right? So this is the spider. You got the case that can actually roll freely, and this roller can slide in and out on that CV joint case. You ever rebuilt a CV joint? Yeah? Repack it with grease and all that. So you need a lot of lubrication there. Usually the first time you have a crack on the boot, right? This is the rubber boot, and that's the protection to keep the grease in there. If you have crack on that because of the fatigue, right? Remember fatigue in machine design? So rubber cracks, water comes in, water plus grease, not good. Okay? So it's gonna basically get dirt in and all that.
Its function is to transfer the power transmitted from the transmission to the wheels through certain angles and axial motion. The cage supports the ball in between the housing, which acts as an outer ring and inner race to allow smooth rotation. GMB's precision bearing products accomplish an optimal driving environment.
Okay, this goes into more detail.
At first glance, drive shafts and their operation seems pretty simple. I mean, they just transmit torque from the gearbox to the wheels, right? Unfortunately, it's not quite that easy. The complexities that vehicle manufacturers must overcome to get that torque to the wheels in a reliable, vibration-free package means that numerous types of systems are used. The purpose of a drive shaft in a light vehicle is to transmit torque from the transmission to the final drive, or in the case of a transaxle, directly to the wheels. In order to do this, the drive shaft must be able to work through varying angles and alter its overall length to accommodate movement in the suspension. Not all drive shafts are constructed the same. The components that allow for a change in drive angle will differ to some degree when comparing a front drive transaxle to a vehicle utilising a live rear final drive. Tail or propeller shafts are used in rear-wheel, four-wheel and all-wheel drive vehicles and are located between the transmission and the final drive assembly. Propeller shafts may be constructed from steel, aluminium alloy, or in some cases a carbon fibre composite. Weight is minimised by constructing them in a tubular shape so that strength is not compromised. A universal joint is used at either end of the shaft to allow torque to be transferred through two or more angles. Some shafts are even fitted with a spline slip joint to permit change in length with suspension travel. Not all tail shafts are fitted with mechanical joints. Vehicles designed with independent rear suspension use a rubber coupling mounted at one or both ends. Because there is very little to no angle change between the final drive and transmission in these vehicles, the tail shaft remains relatively straight. With no angle change, a universal joint is not required. The rubber coupling allows for very small movements in the vehicle chassis or body while absorbing driveline vibrations. Universal joints allow the propeller shaft to drive through an angle. The most common type we will need to repair or replace is the card-in joint. This universal joint is constructed as a cross and yoke design. The cross or trunnion acts as the inner support for the needle roller bearings, while the yoke holds the bearing caps. Each bearing cap is sealed to prevent contaminants from damaging the rollers and prevent any leakage of lubricating grease.
Again, bearings usually fail due to contamination, and any seal that is broken then is the source of maintenance.
Some universal joints are maintenance free, meaning that the joint is sealed for its service life. Others are fitted with a grease nipple for the purpose of lubrication during inspection. Universal joints are strong and robust. However, they are subject to two major limiting factors: maximum working angle and velocity fluctuations. As you can see in this table, the maximum working angle of a universal joint will decrease as the rotational speed of the shaft increases. The maximum working angle of the tail shaft is determined by the vehicle's suspension design, with mechanical interference between the yoke and shaft limiting the maximum achievable angle. Did you know that during operation, angled universal joints' rotational speed will change 4 times each revolution? We call this phenomenon velocity fluctuations. When a universal joint transmits driving torque through an angle, the output shaft does not rotate through 360 degrees at a constant speed. In fact, its speed varies with every 90 degrees of rotation. If we follow the path of a bearing cap from the 9 o'clock position through 90 degrees, the cap must travel a long distance in a short time frame, so it tends to initially accelerate through this angle of rotation. As the bearing cap passes 12 o'clock, its velocity has peaked. It begins to decelerate to the 3 o'clock position. Because of the angle of the universal joint, the bearing cap has a shorter distance to travel to get to the 6 o'clock position. But it has the same amount of time to get there, so it tends to decelerate through this angle. Again, the cap's velocity has slowed through this rotational angle. The bearing cap continues to rotate back towards 9 o'clock and begins to accelerate again due to the greater joint angle, and therefore the greater distance it must travel. What we have just seen are velocity fluctuations of the joint. If left uncontrolled, this would cause extreme vibration throughout the vehicle. We can overcome velocity fluctuations through phasing, which refers to the process of synchronising the universal joints at either end of the drive shaft so that the velocity fluctuations produced cancel each other out. In other words, we position the two universal joints so that as one speeds up, the other slows down. When a vehicle's suspension compresses or rebounds, the tail shaft must follow the same movement as the final drive assembly. The distance between the transmission output shaft and the final drive assembly will change proportional to the arc that the final drive follows. The tail shaft is designed to compensate for this movement using a slip joint. Vehicles with limited suspension travel use an extended yoke which is splined to the transmission output shaft. As the suspension moves and the tail shaft follows, the slip yoke will slide into and out of the extension housing. Vehicles with longer suspension travel are fitted with a slip joint positioned in the tail shaft itself. This joint performs the same function as a slip yoke. It's not uncommon for long wheelbase rear-wheel drive vehicles to be fitted with a centre bearing,
Usually
which
trucks.
effectively turns one long shaft into two shorter ones. The centre bearing is a sealed ball race mounted in a thick rubber casing, which is then bolted to the chassis or underbody of the vehicle. Manufacturers do this to minimise driveline vibrations caused by the high rotational speeds of the tail shaft, but that's not all they do. Unlike the propeller shaft, drive shafts are manufactured as a solid unit and are used in vehicles fitted with independent front or rear suspension. They are often called axle shafts or half shafts due to their construction.
So here goes a CV.
Constant velocity joints are fitted to drive shafts because of their capability for larger working angles and the absence of velocity fluctuations. CV joints are perfect for front-wheel drive vehicles as the larger working angles allow for improved steering ability. Their location in relation to the final drive or wheel hub is how they are recognised and are commonly referred to as either an inboard or outboard joint. An outboard joint, known as a fixed ball or Resepa joint, contains 6 ball bearings fitted between the inner and outer housing and are held in place by a cage.
So the outer joint only rotates, it does not slide in and out.
Machine grooves or tracks in the inner race and outer housing allows the bearings to slide. This construction permits flexing of the housing during operation. The joint is lubricated with lithium-based grease containing molybdenum disulfide and graphite. A flexible rubber boot keeps the lubricant in and contaminants out. Regardless of the joint's operational angle, the input and output speed is always the same, hence the name constant velocity joint. Inner CV joints are a little different from the outer ones, as they only need to allow for suspension travel and not changing steering angles. We call these joints plunging ball types because they are designed firstly as a slip joint and can be further classified as a double offset, cross groove style, or a plunging tripod. Double offset joints have retained the same components as a Resepa joint, with the addition of a deeper, straight grooved outer housing, which allows for the change in the drive shaft length during suspension travel.
Because if you're turning left and right, you're just playing with angles, right? But when the suspension go up and down, the distance is also shorter, right? I mean, consider this is the transmission, this is the transmission output, this is the wheel bearing. Like in this situation, the distance is this much. When it goes up, it's shorter, right? So you need to slide in and out on the inner joint.
A cross groove CV joint is a flatter design with angled grooves machined into the outer housing.
I think this one is the one
Inner
I
race
see the
and
most.
outer housing share the plunging motion, thereby reducing the overall depth of the CV. Cross groove joints are also used by some manufacturers as the outer on IRS drivelines. Tripod plunging joints are constructed with a central drive, referred to as the tripod or spider. Mounted to the 3 trunnions are spherical
My Honda Jazz has this one.
rollers operating on needle bearings. The rollers slide in machine tracks in the matching outer housing. Again, just like an outer CV, a rubber boot is fitted to keep the grease in and the contaminants out.
When my car shop or mechanic repaired my CV, he forgot to put one of the rings. Man, because I keep hearing this cyclic click every time it goes around at a certain rotational. And then I peek down there and I see one of those rings like on top of like the transmission case. I was like,
Do you still think the
welcome to Indonesia. I'm sure this doesn't happen overseas.
shafts are a simple component? Understanding the complexities of driveline systems.
I mean, it still works because, I mean, two of them already make it work, right? But this missing one. All right, let's finish up with wheel bearing and hub assembly, we just talked about it. It's really simple. I just want you to be familiar with it, and then we'll finish up with the driveline design.
The hub bearing is mounted on the inside of the wheel hub assembly and connects the wheel and the steering and suspension. And
okay, so this is how the assembly looks like, and we are using what is called an angular contact bearing, and we'll talk about it actually tomorrow. So an angular contact bearing. So this is a regular ball bearing, right? This is the inner race, the ball, the outer race, right? So this is the shaft, this is the hub, rotates. Now, the angular contact actually, the problem with this one is it sustains much radial load, but not axial load. Now, an angular contact bearing will not be symmetrical. The outer race is like that, and the inner race is like that. Okay? And this is the rolling element. What does that do? So now, because the contact is at an angle, hence the name angular ball bearing. Now, an axial load is resisted better than this one. When do we have axial loads? I mean, yeah, there are some rough terrains, but when do you see the biggest axial load in a wheel bearing situation? Cornering. Because when you turn, the ground pulls you, like when I turn to the left, the ground pushes me to the left, and my inertia wants to go to the right, right? So you have that situation. So if this is the car, this is the tires, right? That's the force from the ground, but the car, due to inertia, wants to move there. So as a result, your wheel bearing actually has an axial load. The radial load is obvious from the ground, from the weight.
rotates while supporting the complex load generated during driving along with the vehicle load. It is being developed through the reduction of weight and quality stabilization of the steering system.
Okay, so you see the cage there, it's tapered. So the cage is tapered like this to keep the ball there. And So you see, this is not the seal. This is not the seal. This is the inner race. So you see that this is the hub. This is the inner ring, and they have an angle. Okay, look at that. There's an angle. So it slopes to a smaller diameter.
Banding the function from the bearing's own function product to the modularization of peripheral parts. In particular, GMB designs the second and third gen.
Now, in bigger loads, it's actually a tapered roller rather than a ball. Okay, so there are balls for passenger vehicles, but for bigger vehicles, it will be tapered roller. So this will be a roller instead of a ball. Bigger capacity.
Generation modular wheel bearings, including the first generation with Optune Light.
Right? That's all there is to it. The wheel bearing, I mean, age-old technology, nothing fancy there. What you can notice when you have wheel bearing situation is when your noise actually escalates with speed, usually, right? So the faster you go, the bigger the whine, like woo. Okay, so that's can be very faint. It's kind of hard to distinguish. Raise the car on the jack stand, rotate, and you kind of hold the spring. You kind of feel some vibration. Bearing is a very precision instrument actually. So a tiny crack on that thing, like a tiny dent on the inner race, will basically give you that noise. It's a very precision piece of element actually. Okay, so finally, let's talk a little bit on
You're
different
cruising down a
configurations.
smooth highway at high speed, and your car is feeling stable and in control. Suddenly, the journey changes. You're now navigating a snow-covered road with limited traction. Later, you find yourself on a muddy trail, the wheels spinning and struggling to find grip. Finally,
You have friends who love to go off-roading? No? Oh, you do? Oh yeah, you have that X-Trail thing, right?
you're climbing a steep, rocky incline, with every wheel fighting for traction to keep you moving forward. What makes your car adapt to these wildly different conditions?
Do you do any extreme off-road or just...
I go with the pilots. So we go mountain, mountain,
Wow.
rivers, cross rivers.
Wow.
We have a group, actually, Hilux group.
Yeah.
So we go like maybe each 2 months, maybe once.
Oh,
We
cool.
go grill or camping together. Yeah, stuff like that.
Cool.
Here comes the different drivetrains: rear-wheel drive, front-wheel drive, all-wheel drive, and four-wheel drive. To understand this, let's start with a key component of all these systems: the differential. Imagine
No,
a
we
simple
discussed
car
that.
axle with this car equals differential speed in. Wheels focus on. Now let's zoom out and look at the bigger picture, how this fits into the world of drivetrains. First up, rear-wheel drive. This is one of the most classic and performance-oriented drivetrain setups. Let's break it down. The engine's power goes through the transmission. From the transmission, the power flows through a long drive shaft that runs to the back of the car. The differential receives the power and splits the power between the two rear wheels, allowing them to rotate at the same speed. The differential also allows the wheels to rotate at different speeds when one wheel loses traction. These wheels propel the car forward, while the front wheels focus on steering.
By the way, have you ever noticed that in the movies, when they accelerate really hard, so when they accelerate really hard, say they're getting away from a bank robbery, the tire marks are only on one side. Why is that? What does that tell you? on one, not on both? It's because it has a what type of differential? Open differential, right? And so when one tire slips, you lost the traction here. Not lose the traction. You lose the torque here. So all the torque goes to the slipping wheel. And that's why you see only one tire marks. If you have torsion, then it's different, or some kind of better LSD, okay, limited slip. But in open differential, you'll see that you can only spin one side.
Separation of steering and power results in more precise control. Rear wheel propulsion allows for sharper acceleration, especially in sporty or luxury cars. In slippery conditions like snow or ice,
By the way, you definitely need LSD if you want to drift, because otherwise you only slip one side.
rear-wheel drive can struggle, as the rear wheels may lose traction more easily. But not all driving scenarios are the same. So, how does this compare to front-wheel drive? Let's find out. In front-wheel drive cars, the engine and transmission are usually mounted together in a single unit called the transaxle, located at the front of the vehicle. The engine generates power, which passes through the transmission, where gears adjust speed and torque. The differential, integrated into the transaxle, splits the power and sends it to the front wheels through CV axles. These wheels propel the car forward. The front wheels not only handle wheel rotation to move the car forward, but also manage steering. Just like in rear-wheel drive, the differential allows the wheels to rotate at different speeds when one wheel loses traction. But compared to rear-wheel drive, front-wheel drive cars are less suited for sporty driving dynamics. Front-wheel drive is all about practicality and efficiency, making it perfect for everyday use.
Okay, why is most passenger cars front-wheel drive? What's the number one priority of a mom with 2 kids when they buy a car? Fuel efficiency, money, right? So, a front-wheel drive is just cheap, okay? You don't have the center shaft, you don't have many different big stuff. It's the most compact, the lightest, the simplest, and the safest. Because understeer is actually better than oversteer. Any snow in Mortis? No? If you drive in the snow, man, you thought understeer is annoying because like every time I turn, when I was in the States, every time I turn, it kind of don't want to go straight, right? And then you'll hit the curb, you'll need another alignment, fix your bent control arms, ball joints. But oversteer is not just annoying, it's actually dangerous. Because what happens, like the scene you see before, in an oversteer, you can actually spin. And it's actually easier to correct an understeer. So if you go into understeer, what's your first reaction? I mean, you just keep turning, but it keeps slipping, but psychologically, you're gonna release on the gas pedal, right? Because, okay, we're out of control. And so when you release the gas pedal, the car slows down and you start to gain traction again. Once you get traction, then you'll turn. And then everything is back on track. So an understeer, if you drive in the snow, an understeer will feel like a delay. You know, you turn and then it understeers first and then it goes into. So you feel like you're going like that. Okay? It's like you turn and you gotta wait 1 second and then it grips. You turn, you wait, so it floats a bit and then it Now, because it's front-wheel drive and front steering, obviously, the torque is on the wheel that is steering, right? Does that make sense? Okay? The torque, the power is on the wheel that is turning. Therefore, think of it like pulling, right? A front-wheel drive actually pulls the entire car chassis. So, when you go into this situation, you turn and it pulls here, right? And then you're back straight. And let's say you are in this situation. You just turn to the right and it's going to pull to the right. So it's simple. Compare this to a rear-wheel drive situation, right? So in a rear-wheel drive situation, the car is being pushed. If you are in the middle of the car, right? The rear wheel push you. But the steering is on the front. So when you steer to the right, the front does not have power. Okay? The front does not have power. This is the engine, most of it is longitudinal, right? So the push is from the back, but this thing turns to the right. What happens? The car spins, right? Because I'm being pushed, but the front wants to go right. So the front wants to go right, the rear wants to go straight. And so you introduce a spinning motion. Now, if everything have good traction, everything's fine. But if you're on ice, then you go that way. So you try to correct, right? So you are in this situation. You try to correct the oversteer. I keep messing it up in my brain. Okay, so the rear slips, but the car is rear-wheel drive. When you try to correct it to the left, okay, this push this way, this push this way. So oftentimes, you actually oversteer again. And so what happens on snow driving with rear-wheel drive, of course I'm talking about no control here, no slip control, no stability control from the computer. You're going to do that like 3-4 times and then you'll be on track. So rear-wheel drive, great traction, because when you accelerate, the center of gravity moves to the back, and the rear gets more traction. It pushes you even further, which gives even better traction in the back, and so it kind of builds on itself. That's why sports cars are rear-wheel drive. But for passenger cars, front-wheel drive is the way to go because it's simply safer. It's just safer to drive, especially in four-season countries.
But what if the road disappears? The terrain gets unpredictable, and you need to drive anywhere, no matter how rough the conditions.
Of course, the best one is all-wheel drive.
That's where 4x4 comes in, giving you the traction and control needed for any terrain. Let's see how it works. Here, the transmission is placed after the engine, and after that, there is another component called the transfer case, which is the heart of the 4x4 system. This component delivers the engine's power to both the front and rear axles. There are two main types of transfer cases, part-time 4x4 and full-time 4x4. The part-time transfer case has one input shaft from transmission and two output shafts to the rear axle and front axle. And there are three modes, 2H, 4H, and 4L. First up, 2 high range mode. Here it receives power from the transmission and sends power only to the rear wheels for regular driving. The front axle is disengaged. It works the same as the rear-wheel drive system. Second up, 4-wheel drive high range. When you need extra traction, The transfer case engages the front axle through a chain or clutch system. This splits power equally between the front and rear axles. Both axles receive 50% of the engine's power, ensuring that all four wheels contribute to propulsion. Each axle in a four-high system has its own differential. These open differentials allow the left and right wheels on both axles to rotate at different speeds. If one wheel on an axle loses traction by being stuck in the mud, the open differential will send most of the power to the spinning wheel. This can cause the wheel with no traction to spin uselessly, while the other wheel, with traction, receives little to no power. So, many 4x4 systems include locking differentials to address this issue by forcing both wheels on an axle to rotate at the same speed. The mechanism inside the differential locks both axle shafts together. Simply, it is likely deleting the differential from the axle. Now it acts like a solid axle, and both wheels rotate only at the exact same speed, regardless of traction differences. Power is evenly distributed to both wheels, ensuring the wheel has a better grip and can propel the vehicle forward. Here, the left wheel has no traction and is not spinning uselessly. The power is evenly distributed to the right wheel, which has traction, moving the vehicle forward. 4H is designed for moderate to high speeds, typically 30 to 55 miles per hour, depending on conditions. Switching back to 2H on stable roads helps maintain efficiency and prolong vehicle life. So when to switch to four-wheel drive low range? 4L is a drivetrain mode designed to provide maximum torque and control for extreme off-road situations, like climbing or descending steep, rocky, or driving through deep, sticky mud. The transfer case engages a low gear ratio, commonly between 2 to 1 and 4 to 1. If the input shaft from the engine rotates 4 times, the output shaft rotates only once. This increases torque 4 times and reduces the speed 4 times. For example, if your vehicle's output is 300 newton meters of torque, here's to the
You
wheel
guys
down,
understand that?
and the ground pushes back with an equal and opposite force. This reaction force propels the vehicle forward. So with high torque, adding a differential lock to this system makes 4L better suited for any challenging off-road conditions. And in full-time four-wheel drive vehicles, there's an advanced component known as the center differential. It adds flexibility by allowing the front and rear axles to rotate at different speeds. But one axle might lose grip, causing the differential to send most of the torque to the axle with less resistance, typically the slipping one. Locking the center differential ensures torque is evenly distributed between the front and rear axles,
So same concept, but front and rear.
preventing one axle from slipping and maintaining control. Let's move to a more modern and automated solution, all-wheel drive. This is an always-ready sibling of 4x4, designed to handle a mix of conditions without different modes like 2H, 4H, or 4L. It does not use a transfer case. Instead, it uses a center differential or a multi-plate clutch to manage power between the front and rear axles. For better understanding, we will take the multi-plate clutch used in modern vehicles as an example. This system has wheel speed sensors on all wheels. These sensors continuously monitor wheel speed. If the front right wheel loses traction, the sensor detects the spinning wheel and sends a signal to the AWD control unit. Control unit engages the clutch plates. This gradually connects the rear drive shaft to the transmission, sending more power to the rear axle. Instead of power being wasted on the spinning front right wheel, the system redirects torque to the rear wheels, helping the car regain traction. And this system does not contain low gear ranges, so it is suitable for on-road performance and moderate off-road conditions.
So, that gives you the flexibility to engage or disengage. You can save fuel efficiency also when you go two-wheel drive only. So that sums up our discussion on drivetrain, drive axles, and any questions, any topic you want to discuss?
Yes, sir.
Yeah.
You said for like passenger cars, mainly front-wheel drive, right? But
Yeah.
older passenger cars still have like rear-wheel drive.
How old?
And like my dad's car,
Which?
Velos.
Oh, personal
7
grudge against Avanza product line because I think it's a truck added with a cabin. And I think it's just an old platform. And some people use it to actually bring cargo in their cars. So it's just, I think it's just the old platform. And if you fully load the car, then you need better traction. But really, it should be front-wheel drive if it's a real passenger car, in my opinion.
Depends on the market also.
Mm.
Because I didn't know that there's a Honda Jazz has come all-wheel drive,
Mm.
and it's I think only sold in Japan.
Yeah.
And then there is one that is front-wheel drive only. This is like
Yeah.
the typical normal market. And there's one also rear-wheel drive only. This is like most the South African type market. And I didn't know that.
Honda Jazz?
Yeah.
Rear-wheel drive?
Yeah. I didn't even know the all-wheel drive. I always thought that it was only four-wheel drive. I know there was
It's
all-wheel
so
drive.
weird because it's a tiny car.
Yeah.
It's a tiny car. It's meant for efficiency. Interesting. I know there were Civics that was all-wheel drive.
Oh,
in the-
the EJ,
yeah.
the EK9.
Mm.
These are the OG dream cars. Yeah,
Yeah.
it's like my dream car. No, my next project car.
Really? An all-wheel drive Civic.
Yeah. So I wanted an EK4 or EK3.
EK will be what year?
04. Yeah, 04.
Yeah,
No,
early,
04.
early
Early,
20,
yeah.
Mm.
Early. The EK9 is shorter wheelbase than all-wheel drive, but EK3 is longer.
I see.
But lower.
Mm.
EK9 is more hatchback, but this one's like more sedan.
What kind of engine?
So it usually has a D15 or D16.
D16 is an old one.
Yeah, it's a good one.
Really old.
Yeah, really old.
My first car was a Civic Si 1993. EG.
It's a
It's an EG.
Yeah, EG. There's a couple of EG in
Yeah,
Singapore, and yeah, I really like this car. And this is like so right now in my country we have CC ranking. So we have slalom. So we do slalom. So that's what we do. So my shop's car is a BMW. So but it's only in the 2000 cc
Category. Yeah.
But the other cars, each garage has like 1000 cc, the best engine, and then the 2000 cc, the best engine they can make. And then they represent their garage in the slalom, and then they put stickers. This is how we market our garage. So that's why I want to build each engine category like the best that I can deliver.
Yeah.
So
So is your garage mostly marketed toward enthusiasts or just a repair?
No.
General repair.
actually we started. I started working at Nissan. I went to Alfa Romeo. I went to Honda, and then lastly at Porsche. So when you start working at companies, you get outside work.
Yeah.
And then I first started at home, like a couple of family, and then family like refer you to people, and then it goes on and on like this. And then at some point, you start getting a lot of job. So this is when there's me and my cousin. We started getting together to work, because after work I finish at 5. So when you get client, you finish at midnight, 1 o'clock. So yeah, you need help.
Yeah.
So when we started, you get quite a lot of money. It's
Yeah.
like a decent amount of money for like at that age.
Yeah.
Even people, I was earning more than my
Yeah.
most of people.
That's cool.
And then I was like, maybe I start opening my own garage. So I opened my own garage, and to market it, me and my cousin and everything, we decided to take a BMW and then
Yeah.
just modify it. And then we kind of diversified, because my dad's, back then, our main business was de-rocking. So we owned quite a lot of trucks and excavators and stuff like that. So I was in the way big diesel, not like small, big diesel. So we started going to random site. So we started with my dad's company, and then we were working with there, and then there was like this operator, and then he quit our company and went to other, but he still know me. So when the truck break down, like give me a call, like I need this. So and then the owner was gonna call me, and then the owner is gonna refer it. It goes on like this, and then we built quite a big client base.
So your customer is pretty diverse, you're saying?
So now I wanted to go in boat, marine. This like you earn big money, like lots of money, big engine for boat, because we are an island. So we have lots of boats.
That's right.
We're an island, so we have lots of boats. But not a lot of people do this kind of job, because firstly you need a lot of equipment. So the thing is, fortunately we have our equipment. Diesel equipment is, so for example, to make a servicing on a normal, let's say on a Jazz, you need only like 14 spanner, and then the basic 21 to remove your wheels, not that much. But when you move to a truck, the whole spanner changes, the gun changes, the torque, you need big air compressor gun, so fortunately we do have all that. But when you move to marine also, it's a different.
Different tool sets.
Yeah, it's different tool set. And mostly it's made by Yamaha. Even for,
what kind of engines?
The engine is vertical.
Yeah.
So,
okay.
Yeah,
The power boats.
Yeah, the power is vertical. And I don't know.
Right?
Not 4-stroke. Yeah, there's 2, there's 4 also.
Yeah.
But mostly the new one is 4-stroke. But yeah, I don't know. I wanted to. But now I'm going to EV, and EV is a different tool set also. So truck has software, right? BD, it's a different software. And then you have car, it's a different software. And then if you go board, it's a different software. And you go EV, it's a different software. So that's the thing.
There is not much maintenance in EV though, right?
There's repair. For example, right now most Mercedes EQS, the engine has a cooling system. So the main engine, the induction engine, has induction motor, has a cooling system. And what happens is there's a small seal in between that's separated, and it leaks into and burn all the inside. So to repair that, it's like a big procedure.
It is.
Yeah, there's only one shop in my country right now that is doing that. So the thing is, Mercedes bring the EQS. They don't have the technician themselves. They bring it to an outside company. There's only one. It's not even a company, it's a showroom. But the tech there, he's very knowledgeable.
I see.
He's young, not young, but in terms of technician, like his age is quite young. He's like around 30-ish. For a technician to be able to have this kind of knowledge, it's a lot. So me, what I wanted to do was, when I do have EV knowledge and everything. I know how to repair stuff. So let's say I want to go to, let's say Mercedes bring a car and they don't have the sufficient labor. So me, I want to be the official retailer, like let's say Samsung have official retailer for their phone. I want to be the official tech shop for like Mercedes, Toyota and stuff like that.
And you have to take certifications for that.
I need to take their training, but I need to have my own. So they don't have EV technician themselves. So me, I went to China, right? So I'm based mostly BYD, Mercedes, and the China type chassis. So when I get the certificate, I can take that and go to them like, hey, I have this certificate. Now I need your training on top of mine.
Yeah.
Because the thing is, let's say I do their job, I need a warranty.
Yeah.
They can't go to any shop because they need to give me their software for me to do their
troubleshoot.
Yeah, their working and everything. So to be able to do that, I need a basic certificate first to bring that to them, and then
they'll train you further.
And then they'll train you further. Yeah. But right now my goal is Monster Tech. Like I want to be the youngest Monster Tech in Mauritius. There's only back then there was only 4. Now I don't know how much. There's only 4 Monster Tech on the whole island, and 2 is owned by Lille Group. Lille Group, they bring McLaren, Lamborghinis and stuff like that. And the other 2 is one was it Volkswagen, and the other one is Hyundai. And yeah, and when you go, the training, they send you to South Africa. And I was talking to one of the master tech there. He told me there's around, in one exam, it's around 1,500 people, but only a couple of 50 to 100 posts maximum.
Wow.
It's like very, very hard.
In
very,
South
very
Africa, training.
Very hard exam. And the thing is, it's all over the world. People send, like in UK or whatever, they send their tech over there and they train for, I don't know.
Who did the training?
I don't know exactly who the training. But you need to be a dealership to send your tech over there. You can't be, me
I
as a
see.
technician, I cannot go there on my own.
So
So
it's
I
like
need to be employed.
It's like a recommendation.
Yeah, I need to be,
By recommendation.
yeah, I need to be employed by a
Mercedes or-
certified dealership. For example, Toyota, Mercedes, and everyone's gonna send them Master Tech. So Master Tech is, so you have me right now. I'm grade 2. So you have the normal intern just coming. You have grade 2, grade 4, 3, 2, 1. You have the chief of like the garage, and then you have Master Tech. So right now I'm grade 2. I need to be grade 1 and chief, and then when I get chief, they're gonna give me training for a couple of years, and then I can go Master Tech.
Oh, that's cool.
Yeah.
So I mean, this is the advantage of living in a tiny country, right?
But I think you need to know people also. That's
Yeah.
the problem. They don't send, because the thing is, let's say they know me, because me, to be honest, I didn't go there for the money. I went there for the knowledge. So the guy is like, yeah, you're gonna take the knowledge and then you're gonna go away. they don't want to, and it's not that they don't want to train you quote unquote, it's like they don't want to invest in someone that's gonna go away. So most company, what they do is they don't even give you 5-year contract, they give you like 10-year contract, because it's that hard. It's that hard, and people poach you, like other companies, like come. And the funny thing is, most of the time they don't even do any job, to be honest. So what they do, they supervise.
They supervise junior mechanics.
And the only time they get job is like one complex.
Very
so
complex
you have like all the
situation.
below. If all these people cannot do this job, only then you will do it. Yeah, and it's quite interesting. And most of their master tech is electronic based. It's very rarely mechanical, because mechanical has a certain logic to it. So this one is not working because of this one, because it's connected to this one. But electronic, you have canvas and all the high and low, electronic, all the
Right. You cannot
stuff.
see it.
Yeah, you
it's
cannot
not
see
as
it. So
logical.
it's more troubleshooting, and
You need the theoretical understanding.
exactly. So that's one of the reason I came SGU.
But why do you need the bachelor degree?
I don't need the
Oh, okay.
I just need the HEV certification that says HEV, so I can take it to a dealership. Like, yeah, I have this.
Okay. But you have one from China, right?
Yeah, I have to. But I already started this. Might as well finish it. And here I get the connection from China because of SU. So
Yeah.
maybe along the way I can get like more connection.
Okay.
And it's not like I'm rushing. Like
Okay.
there's nothing good come from rushing. You need to take things slow, and
But
I do learn lots of stuff. So.
do you enjoy Indonesia so far?
Depends what you enjoy. It's like, yeah, it depends.
Okay.
In terms of
Because you're stuck here for like a long time.
4 years.
4 years.
Yeah, 2 years already gone, so
Mm.
2 years remaining.
But you go home often?
Yeah, I go home every semester. I go home.
Okay, every
Yeah,
semester break you.
Every semester break I go home. So one semester I have 4 months, and then the rest I'm either somewhere or I go home. So last time I went to South Africa, and then I went to Mauritius. Then before that, I went to Turkey, and then I went to Mauritius. Then before that, I went to China, and then I went to Mauritius.
Do you have any girlfriend in Mauritius?
Yeah, actually I'm getting married.
Oh,
Yeah, that's why I went to South Africa. Getting married July.
this July.
This July.
All right. Okay. So your wife's moving here with you after you get married?
She's gonna stay in South Africa, and then when I finish, she's doing her masters.
Oh, I see.
Yeah, her masters. So
In South Africa.
in South Africa. She's South African Chinese.
Oh, interesting.
Yeah.
Okay.
But yeah, we're gonna mostly go to Mauritius because Mauritius is better place.
Hey, do the post test.